As we look up into the endless night sky, AED by the serene beauty of distant stars glimmering across the cosmos, one question echoes through the vast silence of space. A question that has lingered in human consciousness for generations. Are we alone in the universe? With every flicker of light from the heavens, it feels as though the cosmos itself invites us to seek answers. For centuries, this question remained in the realm of philosophical musing, spiritual reflection, and imaginative
Storytelling.
But today, science is edging closer than ever to offering tangible insights, thanks in part to a technological marvel now orbiting high above Earth. The James Webb Space Telescope, JWST, launched as the most advanced space observatory in human history. The JWST represents a leap forward in our ability to observe and understand the universe. Equipped with cutting-edge infrared capabilities, this extraordinary telescope acts like a powerful cosmic magnifying glass, allowing us to peer into the atmospheres of planets light years away. It can analyze the faintest glimmers of light passing through these alien skies, light that carries with it a fingerprint of the elements and molecules within. With this, we are entering a new era of astronomical discovery, one that could potentially unveil life beyond Earth. One of the JWST's most exciting recent missions focused on a distant exoplanet designated K2-18B. This world, orbiting a red dwarf, star named K2-18, is located approximately 120 light-years from Earth in the constellation Leo. What makes K2-18b particularly compelling is that it falls within its star's habitable zone, the region where temperatures may allow liquid water to exist given the right atmospheric conditions. But unlike Earth, this exoplanet occupies a category scientists refer to as a sub-Neptune. It is larger than Earth but smaller than Neptune, a classification that challenges our existing frameworks for understanding planetary environments. Unlike the familiar rocky planets of our solar system such as Mercury, Venus, Earth, and Mars, K2-18b defies easy comparison. It is neither a terrestrial planet with a solid surface nor a traditional gas giant. Instead, its unique characteristics have forced astronomers to think more creatively and expansively about what constitutes a potentially habitable world. Sub-Neptunes like K2-18b do not exist in our solar system, making their study all the more important for understanding the diversity of planetary systems in the galaxy. Initial data from the JWST has already delivered groundbreaking insights. Scientists found clear evidence of water vapor in K28b's atmosphere, an essential ingredient for life as we know it. But perhaps even more astonishing was the detection of a molecule known as dimethyl sulfide DMS. On Earth, DMS is predominantly produced by marine plankton, tiny microorganisms that thrive in our oceans. The presence of DMS in a planet's atmosphere is particularly significant because here on Earth, it is considered a strong biosignature, a chemical that almost exclusively originates from biological activity. Alongside DMS, researchers also identified methane CH4 and carbon dioxide CO2 in K2-18b's atmosphere. These molecules, especially when found together, have sparked immense interest. Methane, for instance, breaks down relatively quickly under exposure to stellar radiation. If it is still present in significant quantities, it suggests there may be ongoing processes, possibly even biological, that replenish it. Although carbon dioxide is more commonly found in a variety of planetary atmospheres, its co-occurrence with methane and DMS strengthens the case for potential life. It's crucial to consider the unique environmental dynamics of K2-18b. Despite its proximity to its parent star just 0.18 astronomical units away, compared to Earth's 1 AU from the Sun, its surface is not expected to be scorched. This is because K2-18 is a red dwarf star which emits significantly less heat and radiation than our own Sun. As a result, K2-18b may experience surface temperatures similar to or even slightly warmer than Earth's, depending on the nature of its atmosphere. Its thick, hydrogen-rich envelope could trap heat and extend the range of temperatures under which liquid water could exist. This proximity between the planet and its host star also facilitates detailed observations. When K2-18B transits or passes directly in front of its star from our vantage point, a portion of the starlight filters through the planet's atmosphere. The JWST captured this light during a pair of carefully timed 5-hour observation windows. By splitting the light into its constituent wavelengths, astronomers created a detailed spectrum that acts like a barcode for the planet's atmospheric chemistry. Missing or absorbed wavelengths in this spectrum correspond to specific molecules, revealing what gases are present high above K2-18B's surface. But the implications of these discoveries go beyond the data alone. In 2021, astrophysicist Professor Niku Medusan proposed a new class of potentially habitable exoplanets called Hyzen worlds. The term is a portmanteau of hydrogen and ocean, describing planets that are enveloped in thick hydrogen-rich atmospheres and contain vast global oceans beneath. High-end planets are believed to be capable of supporting life, even in environments that are much hotter than Earth. Though they could reach temperatures of up to 200 degrees or C, their dense atmospheres might still allow for the presence of liquid water. K2-18B has emerged as one of the most promising candidates for this new class of exoplanets. If it truly fits the Heen model, it could possess a colossal ocean that makes up the majority of the planet's mass, perhaps up to 90%. These oceans might be shielded beneath thick atmospheric layers, allowing for microbial ecosystems to thrive in deep, thermally stable environments, just as similar extriops do near Earth's deep-sea hydrothermal vents. High-on worlds may also represent a sweet spot in the search for extraterrestrial life because of their large size and relatively frequent occurrence in the galaxy. They are easier to detect than Earth-sized planets. Their extended habitable zones, made possible by heat-trapping hydrogen atmospheres, mean that they may be far more numerous than previously assumed. In fact, some astronomers believe heat planets could be among the most common types of habitable worlds in our galaxy. Of course, confirming the presence of life on K2-18B or any exoplanet remains a daunting task. While the detection of biosignatures like DMS and methane is thrilling, it is not definitive proof. These molecules could, in rare cases, be produced by non-biological processes. The next steps involve continued observations, rigorous modeling, and eventually next-generation instruments capable of detecting even fainter and more complex molecular signals. Nevertheless, the possibilities are exhilarating. The discovery of a planet that exhibits Earth-like biosignatures, or even just one with liquid oceans under a foreign sky, would mark a monumental turning point in human history. It would not only redefine our place in the universe, but also open new avenues for exploring how life might arise and evolve in radically different environments. As the James Webb Space Telescope continues its mission, we can expect more revelations about K2-18B and other mysterious worlds beyond our solar system. Each discovery brings us closer to answering that most profound of questions, whether life exists elsewhere in the cosmos. Until then, we remain on the edge of cosmic understanding, watching the stars with curiosity, wonder, and hope. Let us know your thoughts in the comments. If this journey through the stars fascinated you, consider subscribing for more content on the search for alien life, planetary science, and the latest from space exploration. Share this with fellow stargazers, and stay tuned for future deep dives into the most captivating mysteries of the universe.